In our last video, we saw random forest regressor, how to apply random forest algorithm for a regression problem using scikit-learn. Today we'll be seeing random forest classifier, how to apply random forest algorithm to a classification problem. For that, let's pass on to a video. As I told you before, today we'll be seeing random forest classifier. For that classification problem, right, we are going to use this data. The same dataset which is used for decision tree classifier, we are going to use it here for random forest classifier as well, right? Pregnancies till age is the features. Glucose, blood pressure, skin thickness, insulin, BMI, diabetes, pedigree, function, age are the features for this problem. Okay, outcome is the y variable or the target variable. This is the dataset which you're going to use. First, we can have the recap for what are the libraries needed for it. What are the libraries used for decision tree classifier has been mostly used here as well. Okay, or the regressor or the random forest regressor. Mostly all the libraries are used here, except one or two is changed. Panda is there. Train test split from sklearn. sklearn.ensemble. This is the one more important thing. sklearn.ensemble import random forest classifier. Last thing, we use random forest regressor, right? And since it is a regression problem, now we are using random forest classifier since this is a classification problem. Okay, since the outcome target variable is 1010, it is as a classification problem. Okay, then we are importing from sklearn import metrics. Data set is a CSV file, so pd.tracecsv from vn data and printing the data. Then I locate 0 to 8, that is totally 9 columns. Since it starts from 0 till 8, so 9 columns is selected for the x variable. Okay, that is the features for us. Okay, 9 column is arranged to the allocated to the target variable. 0 1 2 sorry 0 1 2 3 4 5 6 7 8 has been given to the x. We assigned to the y, right? X and y variable is printed, right? X and y variable is printed. X train, x test, y train, y test, train test split. Okay, with that we are splitting the data into test and training, right? Test size is 30%, that is 0.3, and random state is 1, and the training size is 70%, 70. Okay, classifier is equal to random forest classifier is the algorithm is called here. N estimator is equal to 10. This is one important thing which you want to focus here. N estimator is the number of decision tree which you are going to use for this random forest algorithm is 10. Okay, if it is 10, then we are going to use 10 decision trees to combine the random forest algorithm. Okay, from that we are going to get the output. From that 10 decision tree, 10 outputs will be drawn and combined at last. N estimate equal to 10. Then classifier, we are fitting the x train and y train data. We are fitting the training data to the algorithm. Y predict equal classifier dot predict x test as in type. Then we are printing the y test and y predict. The y predict classifier is changes int as well. Y test is the testing data and y predict is the data which we have predicted using the features alone, right? Accuracy metric equal to for the y test and y predict. Matplotlib import pyplot as plt, sklearn import tree. Fig equal to plt dot figure, tree dot plot, plot underscore tree classifier dot estimate of 5. That symbolizes, right, we are going to visualize the fifth is called the 6th, since it starts from 0 0 1 2 3 4 5, that is 6th decision tree will be plotted for this. Okay, then for this, right, the 8th decision tree is will be 9th decision tree is plotted here, right? Now we can run it now. Right click, run RFC, that is stands for Random Forest Classifier. Python file is running now. How it is run. First of all, we printed all the whole data from pregnancy till outcome. Then we have printed the x values alone. Okay. 50 rows into 9 columns, right? From x. Okay. It's allocated there. Y. Outcome. Y is the outcome, right? Next, y test. Testing y data is printed here. Then the predicted y predict values. The accuracy seems to be 0.73. It's a good accuracy though. The sixth decision tree is, since it starts from 0, the sixth decision tree is displayed here. Is plotted. Have a snapshot in your mind of this decision tree. After closing this, right, the 9th decision tree will be plotted. I'm closing it now. This is the 9th decision tree. As you can see, the layout changes from the 6th and the 9th, right? There will be some difference. That is because the estimators keep on changing. I'm closing it now. The code is run. Process finish with exit code 0. Without any error, the whole code is ran. Estimator is the one important thing here. For example, right, if I'm changing it to 11 instead of 5, 11 is equal to 12 in this thing. We have given only 10 decision tree, n estimator is 10. So if I'm giving 11, right, automatically it shows some error. There is no 11th decision tree, it will throw error. Now I'm running it now. There are list index out of range. That is, it is saying that there are only 10 decision tree. You are asking throwing 11th one. This is not available in the index. I'm closing it now. 10. Even if I'm giving 10, it won't run. That is because it starts from 0 till 9. Totally 10. It will throw the same error. List index out of range. It starts from 0. If I'm giving 9, right, it will run on the whole and display the 10th decision tree of this random forest algorithm. This is 10, right? 0 to 9. 10th decision tree layout this. I'm closing it now. It is ran now fully without any error. This is Random Forest Classifier. Okay. You have a small recap on classifier and Random Forest Classifier regressor. This is the regressor one. N estimator, what is N estimator, and Random Forest Classifier. And what is N estimator, and how to give the range, how to visualize using the estimator. Okay, what is the range we should give, and so on for the tree. This is about Random Forest Classifier and regression. How to code using Python and scikit-learn. This is about Random Forest algorithm alone. So how to code it in Python we saw today. In the next video we'll be using another ML algorithm. Until then, it's me Vignesh here. Thank you.